Good morning and happy Tuesday. So this will be our last lesson of the school year. I'm going to stretch it out and I'll give you a take-home quiz to finish off matrices. So as promised, how are matrices helpful with systems? So let's take a look at this first system here. 2x plus y equals 5. And then finally x plus y equals 3. So you're probably already thinking some combination 1 and 2, right? Okay, so here's the thing. If we kind of unmultiply the matrix, so if we take the coefficient of the first equation, 2 and 1, make our first row matrix, and then make a 2 by 1 column. Like if we were to multiply this matrix, it'd be 2 times x, 2x, and then 1 times 1 is positive y. So if we take that first row, make the first row of the matrix x, y, we'll set it equal to matrix 2 by 1 of 5. Then we do the same thing for this row 2. Take the coefficient 1, 1, and if I were to multiply this matrix, this row by this column, you'd get 1x plus y equals 3. So you have here a 2 by 2 matrix, so let that be matrix A. Here's a 2 by 1 matrix, gives us a 2 by 1 matrix. So first thing we need to do is, we can't divide, there's no such thing as dividing matrices, but we're going to let this be A, and we're going to try to find its inverse, kind of like find the reciprocal. So off to the graphing calculator I go. Second matrix, I have to edit. So in my matrix A, I'm going to enter a 2 by 2 matrix, and I'll enter the coefficients 2, 1, 1, 1, right? So now get out of here, and I'll go back to matrix and select number 1 for the matrix A and find its inverse, its reciprocal. Now keep in mind we want to store that. Okay, so you might want to write that down. Again, in college you probably won't be able to use this, but that's your matrix A. Okay, inverse, excuse me. So I'm going to write that down here. So that was 1, negative 1, negative 1, and 2. Okay, and I'm going to store that into matrix B. So don't forget, hit the store button and go to second matrix and select number 2, and I'm going to store that in B. So if I go back into matrix, I have A and B, right? Now, decisions. Now that I stored in matrix B, it's a 2 by 2 matrix, I have to decide. I can't divide, I want to get the x, y by itself. So I have to multiply. Do I multiply it from the left, or do I multiply it from the right? That's the important part. So let's go back here. 5, 3 is a 2 by 1 matrix. So where do I put the inverse? Well, I know a 2 times 1, if I put this on the right and multiply it by that inverse, the row and the columns don't match. But I know if I squeeze A inverse here in the front, I will be able to not only cancel it out here, but over here I'll be able to get the answer. Now, the beauty behind this, okay, again, why does this work? So let me take them. So let's take the first matrix A, and we're going to multiply it now with matrix B. See, if you multiply the two, guess what you get? The identity matrix. Woo-woo. So I need to find this matrix a location. So next letter available is matrix C. So I'll choose matrix, oops, can't choose it yet. So let's go to second matrix and edit matrix C. So we're going to make this a 2 by 1 matrix, and let's enter 5 and 3. And now it's there. We're going to take matrix B and multiply it with matrix C, and that'll give us the answer. So we know, therefore, that x, y was equal to 2, 1. So that tells me the point of intersection was 2, 1. Pretty nifty. You probably think I could have done that quicker algebraically. Yes. But you might recall we had 3 variable systems. So there are larger systems out there. So the matrix algebra comes in really handy. Let's do another example here. So again, if you want, might get kind of confusing, go ahead and reset your calculator to its original. That way you can start fresh A, B, and C. So again, first things first, let's break up the matrices. So, I already have it started here for us. So 3, negative 1, x, 4, that's the first row. 2, 1, 1. So now remember, this will be matrix A, so I have to enter that in. Great. So matrix, I got to enter matrix A. That's going to be a 2 by 2 matrix, and the entries are 3, -1, 2, and 1. Now, get out of here, go to matrix A, and find its inverse. Now, unfortunately, it kind of happens every now and again. You do have decimals, not a problem. We're going to store that into matrix B. Okay, so A inverse is going to be the matrix 1/5, 0.2, 1/5, 0.2, -2/5, -0.4, 0.6. Now remember, we want to get x, y by itself. So remember, the dimensions is very important. So what are we going to do? We're going to multiply 0.2, 0.2, -0.4, 0.6 to the 2 by 1 matrix 4, 1, and that will give us our answers. Of course, I need to get 4, 1 in my calculator. So second matrix, let's put that in matrix C. And that's going to be a 2 by 1 matrix. So we're going to enter here 4 and 1. And now get out of here, and we're going to select matrix B times matrix C, and that'll give us our answer. So x, y was equal to 1, -1. Neat, isn't it? All right, so now here comes the challenger, what we've all been waiting for, the 3 by 3. So this was the exact example number 6 from homework assignment. We first started off your systems. So again, might just help to reset your calculator again. I have no programs here. I'm not worried about losing any. But again, first things first, create the 3 by 3 matrix, right? So there's your first row, then the second row, and we want to enter this in matrix A. This was matrix C, and what's going to enter in matrix B would be the inverse. Let the calculator find the inverse, okay? So, So second matrix, let's enter into A, our 3 by 3 matrix. Very carefully, 2, -4, 2. There's row 1. 5, -3, 5, row 2. 4, -5, 2, row 2. And then quit out of there and hit second matrix A. We're going to find its inverse. I'm going to expect decimals. Not a problem. I won't even bother writing it down. Store that into matrix B. All right. Now we have to enter in matrix C, which will be our 3 by 1 matrix of 4, -4, and 8. So remember, this is a 3 by 3 matrix, multiplying that by 3 by 1. The end has to match the beginning. So we're going to take matrix B first and multiply that with matrix C. And ta-da, there's your answers. 1, -2, -3. So you could leave your answer as a matrix, because those of you remember, I always said there's a topic I would love to teach you, matrix algebra, before I do vectors. Doesn't that remind you of a vector? All right? So the two go in hand. So I'm not sure why we won't do one, not the other. And turns out the IB Math 1 kids going IB Math 2 will never know the difference between a vector matrices because they'll never see it, presumably. So go ahead, try the 2 examples I gave to you for homework as we finish off the course here. Hope you appreciate this. And if you have any questions, just let me know. Thanks.